Howdy, this is Samantha Tabor, and I am doing my audio report on Ohm's Law for our full lab report project. So, the goal of this experiment was to gain a better understanding of the relationship between the voltage and current across a particular material, in this case, a resistor. In this experiment, we tested what would happen to the relationship between voltage and current through both DC and AC circuits. The AC circuit trial was split into two different waveforms, being square and sine formations. The theory at play in this lab is Ohm's law, which states that the current between 2 points is directly proportional to the voltage between the same 2 points. This is defined with the formula V equals IR, where V is voltage, I is current, and R is resistance. To perform this experiment, we used the LabPro interface, a source of power, the Vernier power amplifier, patch cords, a voltage sensor, a current probe sensor, and an unknown resistor. We first set up a DC circuit where we manually increased the voltage by turning the voltage knob on our power supply. Then we set up an AC circuit and used the LabPro software to adjust the waveforms, then let the software collect the data and create a graph. These graphs showed us that voltage and current have a directly proportional relationship. We expected to have a slope near 100 for each of our 3 trials because our resistor had a resistance value of 100 ohms. This held true for all 3 of our circuits, with resistance values around 98.6, 95.1, and 96.9. We also ran the square and sine AC currents at 3 different frequencies of 100 Hz, 60 Hz, and 30 Hz. From doing so, we concluded that differing waveforms could result in different accuracies. In our case, the square wave had a stronger correlation at 0.969 than our sine wave did at 0.976. Despite being the same frequency. We also concluded that as frequency decreases, the more accurate the resistance becomes. At lower frequencies, the resistor is able to resist more, resulting in a steeper slope that is closer to the value of the resistor. One possible source of error could be a discrepancy somewhere in our circuit. This could be due to incomplete attachments of patch cords or the assumption of ideal wires in a less than ideal world, causing the electric or the voltage to escape somewhere down the line. Overall, the experiment was relatively easy to follow and the data was easy to collect, which in turn allowed us to obtain accurate results.